Okay, good morning everyone, or good afternoon, depending on what time of the day I see you. Today we're going to talk about expressions. It's very important to know that expressions do not have an equal sign. That is an expression, just two terms that are not alike, no equal sign. Same thing here, same thing here, same thing here. We're going to work on figuring out whether or not certain expressions are equal to each other. Question like this: which two expressions are equivalent to the blue expression? I made a big blue expression here. We've got to figure out which ones, and this is just really important. Don't just find one and answer it and move on to the next one. Make sure you know you're answering two of them will be equal to this. So in this case, I would just distribute, multiply 2 times 2x, I'd get 4x. 2 times 4y is positive 8y, and I already know that's not the right answer. 2 times 8 is 16, and plus 12. And I see a positive 8y here. I'd add this together, I'd have 28. Nothing about that looks equivalent to 4x minus 8y plus 12. So on to the next choice. It's possible that I would make a mistake though, so if I don't find two that perfectly match this, I'll go back to that. But let's see what happens here. 2 times 2x is our 4x. That looks right. 2 times negative 8y, positive 2 times negative 8 is how I like to have my students look at that. Multiply positive times negative, you always get negatives, and that would be 16y. Again, this isn't looking right. 2 times 4 is 8. Minus 4, that's only going to give me 4. The negative 16y is wrong. Again, I don't like that. With some confidence, I could probably mark both of these and move on, but I want to prove it just in case I made some sort of mistake there. 2 times 2x is 4x. 2 times negative 4y is minus 8y. That looks good. 2 times 8 is 16. Positive 16. Minus 4 is 12. I like this answer right here. And I'll prove this one as well. 4x. And 4 times negative 2 is negative 8y again. 4 times 4 is 16. Minus 4 again, exactly like this one. 16 minus 4 is the 12 we wanted. And if we use our pencil, we should do pretty well with that if we understand the distributive property and combining like terms. Alright, let's take a look at another one. Here we want two expressions that are equal to each other for any value of x. In other words, both expressions should look exactly the same, and these certainly don't. 3x minus 2 and 3x plus 2 are completely different, so I certainly would not answer that. So what I want to convince all of my students to do, and everybody out there, is to go ahead and distribute this 2x plus 2, and then add this third x, or this other x, 2x plus, and we know there's a 1 right there. We never write that one, but there is one. That is 1x, that is 2 x's, that's a total of 3 x's. After I combine my like terms, and plus 2, that looks familiar. 3x plus 2 and 3x plus 2. I certainly like these two answers as equivalent expressions. Again, I'm going to check this one just in case though. So 2x plus 4 plus x would give me 3x plus 4. And that, of course, does not look like 3x plus 2, 3x plus 2, or 3x minus 2. So, a little bit of work, a little bit of understanding of the distributive property and combining like terms, and this should not be a big deal for most kids. Now, when it says that it cannot be equal to each other for any value of x, I want to see quite a bit of work done to prove this. So I've got 6 different possibilities. The two expressions that cannot be equal to each other would have to be a and b, a and c, a and d, b and c, b and d, or c and d. That's 6 different things we should have to try here. I'm going to try going in reverse order just to prove my point here. If I could solve for x, let's say that these two are equal, d and c. So that would mean 3x minus 2 equals 2x plus 3. if I can get an answer for x, that means they could be equal to each other, and it would not satisfy what we want here. So I would always suggest subtracting, when I've got the variable on both sides, subtract the smaller one. So I'm going to subtract 2x from both sides of this particular equation. I'm going to get 1x minus 2 equals 3. I would add 2 to both sides to isolate this variable. Isolate the x by adding 2 to both sides, and I get x equals 5. Because I found a number that works to make them equal, it is not C and D. So I set them equal to each other, and if I can solve it, that's the one I want. Okay, I hope you all understand that. So I've tried C and D, and I have to go through all of these choices to get there, but for the sake of our video, I'm going to try A and B now. X plus 2, it wouldn't matter what order I do these in, equals x minus 3. Again, when I have the dilemma of having the variable on both sides of this equal sign, I like to subtract the smaller one. In this case, they're both exactly the same. So to move it, I would have to subtract x from both sides, and I'm going to get something that looks really strange to kids at first. 2 equals negative 3. I think everyone understands that is complete nonsense. 2 does not equal negative 3. The variable disappeared from both sides. There is no way to solve this equation. Those are the two answers that cannot be equal to each other for any value of x. Now, if you think about it a little bit more, taking a number and adding 2 to it, and taking that number and subtracting 3 from it, of course there's no way it's going to equal each other. Let's say you're 14 years old. When you're 2 years older, you're going to be 16. If you were 3 years earlier, it'd be 11. There's no number that's going to work for x there. So you can kind of figure that out. If you really understand that, that's fine. Otherwise, go through the process of setting them all equal to each other until you find the right answer. And none of these will work, or all of these would work, I should say, but this A, B would not. So let's look at one more of those. Again, you're not going to take a number like 2 and subtract x, and then take 4 and subtract the same value. 2 minus 20 is never going to equal 4 minus 20, or 2 minus 100 would never equal 4 minus 100. So that's definitely going to be our answer. I can prove it quickly when I get a nonsense answer here. I've got negative x on both sides, so I add x to both sides. That cancels out, that zeroes out, I get 2 equals 4. Complete nonsense. And with any other combination of two expressions, I will be able to solve for it and find a value of x that would work. So the only ones that won't work are right there. Thank you very much for your attention, and we'll see you next time.